Okay. So it is about the left and the right hand limits. Okay.
Mm-hmm.
Yes. So the first question. Okay. From the graph, you have the questions. Yes, George.
Yep.
Okay. Given the graph of f of x below, find the following limits they are asking. Okay. So limit x approaches 4 minus. So they are talking about the left hand limit f of x. What it would be?
So from the left-hand side at -4, it's going to be 5.
Yes, very good. Next one. B. Limit x approaches negative infinity f of x. So this side. Okay.
Okay. As first negative infinity, it's going to be 4.
Yes, George, correct. Next one. Limit x approaches negative 4 plus f of x. So that's negative.
-1.
Yes, correct. Okay. Next. X approaches 4 f of x.
D. So, for D, sorry, as it approaches 4, it's going to be 0.
Okay, good. Next one. Limit x approaches negative 4 f of x.
Does not exist.
Yes, obviously. Limit x approaches 3 minus f of x. 3 minus this side. Right?
Yep, it's going to be sorry, minus f. I didn't see that. I thought I said -3, sorry. It's going to be 1.
Yeah, okay. Next one. F of negative 4 is what?
-1.
Yes. F of 3?
F of 3 is going to be 1.
Okay, limit x approaches to f of x.
As it approaches 2, it's going to be 4.
X approaches infinity f of x.
For which one?
J it is. Limit x approaches infinity f of x.
Oh, no, for I. I was doing for I.
Okay. Yeah, I think it's that. Yeah, x approaches to f of x. Hello? Yeah, yes, George.
Sorry. As it approaches infinity, it's going to be infinity.
Yes. Next one. X approaches 3 f of x. Let's go up. X approaches 3 f of x.
3 f of x. As it's going to be 1.
Yes. Okay. Next one. F of negative 3.
F of -3. It's does not exist.
Yes. Okay. F of negative 2.
F of negative. Actually, you know what? Would F of -3? Actually, no, never mind. Sorry. F of -2. Sorry, would just be 1.
Yes, obviously. Okay, good. Limit x approaches negative 1 f of x.
-1. It's going to be 3.
Yes. Okay. X approaches 5 f of x.
As it approaches 5 f of x, it's going to be 1.
Okay. Next one. Let's come here. Find the following limits algebraically. Okay. Limit x approaches 1 minus x minus 1 times x minus 2 divided by x plus 1.
Sure. Let me just get a piece of paper to write that down on. Sorry.
Yeah. Yes. Sure.
It does. Wait. Sorry. Give me 1 second. Sorry. Just give me 1 second. I'm just stopping right now. From the left, would it just be No, actually would it just be does not exist because it's the infinite discontinuity?
Yes. Okay. Next one. What about option C? Okay, we'll try with option C because that one is.
So that's going to be 1 over. Oh, for option B or C? Can I do B? If it's okay, I already solved it.
Yeah. Okay, yeah. You can
sorry. For B, it's going to be 1/2, 1/12.
Yes, correct. Okay, that was simple. That's why I told you to type in C.
Yeah,
Okay,
sorry.
okay. C, what? C. Um,
So it's just going to be -1 then
yes. Okay, good. Next, what
for
about
D?
D?
Oh,
Okay,
E.
yeah.
Okay.
E, can you try because here D is of the, this is like square root we have.
So for that one, it's going to be positive infinity. Actually, you know what? Sorry. I forgot the rules exactly.
If it
Actually, no,
is,
never mind. Sorry.
yeah.
Would it just be uh positive infinity then the limit?
Yes. Okay, fine. Um, okay, what about this L? Sine 3 times x over 3x squared plus 9 times x.
Sorry, I'm not really too familiar with how to use sign. I know I can factor at the bottom, but how would I simplify?
You can, sine 0 will be 0. So just give me a minute. So this one, just look at different. Just give me a second. Let me calculate it. This is 3x squared, right? The hospital. An hospital's rule is not taught to you. Am I right?
What happened?
An hospital's rule is not taught to you. Am I right?
I can't hear you. Sorry. What?
No, no. I'm saying an hospital's rule is not taught to you, right?
I don't think so.
Okay, then we have to go for graphically. You have the graphic calculator with you?
Or wait, I'm sorry. I couldn't hear that. What'd you say the first time?
An hospital's rule is taught to you in the
El
class.
hospital. What rule?
An hospital's rule.
El hospital?
I think it is not taught. It will be coming afterwards. Okay, never mind. So we will just go and see. You can solve this using graphically. That is, you can use a graphic calculator for this, or numerically also. But that is the derivatives we should know. That is L hospitals. Can you just do? You have the graphic calculator with you?
No, I don't. Sorry. Yeah, I don't
Okay,
have it with me. I'm sorry.
fine. So what you have to
So
do
then,
is, if
so
you
then,
are,
oh,
yeah, yeah,
hello.
yes, yeah. Tell me, tell me, tell
Then
me.
can we do them three instead, like 3A, B, C, and D?
Yeah, yeah, sure, 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 sure. For sure. See, one thing I'll just say you for this. This is like infinity over infinity form. Okay. So what you have to do, either you can use a graphic calculator for making out this. Okay. Otherwise, there is a rule where you at this limit when we are not able to solve by infinity over infinity, we will be using L'Hospital's rule. Okay. That you will be studying in your future. Nothing. Numerator I will differentiate. Okay. I will find d by dx of the numerator, d by dx of the denominator. Then I will apply the limit force. So you will get an answer. You got my point? Yes, Judge?
Mm-hmm.
So that when I differentiate this one, this will be 3 cosine of 3x and this will be 6x plus 9. Now if you apply the limit, you will get your value. You got my point? Because cosine of 0, it is 3 over 1 minute. I'll show you there. This is what the L'Hospital is. I'll write it on the whiteboard. Okay. See, what will happen here is, see, it is limit. In future, if it is needed, you can take this one. Okay, now limit x approaches 0. It is sine 3x. Okay, it's divided by, we have a 3x squared plus 9. Okay, what is happening when I apply the limit here is, it is sine 0 is 0. And this one also, it's becoming 0. If it is coming 0 by 0 form, you can use the L'Hospital's tool. Okay, the mathematician thought that I should get an answer for this, right? So what they did is, it's very simple. What is the L'Hospital's rule is? You are going to keep the things as it is, the limits. Okay, you will differentiate the numerator. Okay, George, sine of 3x, and I will differentiate the denominator. Okay, then you apply the limit test. Okay, so in that case, what will happen is, there are proof and what is L'Hospital's rule and all, but I'm not going inside that, and we will get it out afterwards. Okay, just differentiate this. This will be 3 cosine of 3x. Okay, Josh, divided by, this is 6x plus 9. Okay, so what will happen now? Apply the limit. It will be 3. Cosine of 0 will be 1. Okay, and this will be 9. So it will be 1 upon 3 will be 9. Got my point? Certain cases.
I'm
Yeah.
sorry, but Shooter, can I do number 3 now, like the other ones below that?
Yeah. Yes. Yeah. I just wanted to show you what will happen to this. That's it. 1. Okay, that is okay. For 3 f of x they have given. Okay, it is a piecewise function, and you need to find limit x approaches 0 f of x for this. Okay. So I hope when
as x goes to 0, it's gonna be 1 quick second. Does not exist because
yes, D and E
does
because does not exist. Okay, for B,
it's going to be, just give me 1 quick second. It's going to be 7 over 2.
Yes, right. Okay, next.
As it approaches infinity, it's just going to be infinity, positive infinity.
Infinity to be 1 over infinity, which is 0. X approaches
0.
Infinity means it will be greater than or equal to 0. Am I right?
Yeah.
So it will be 1 over infinity plus 1. Infinity, when you add it with anything, you will get again infinity. 1 over infinity will be 0.
Oh, 1 over infinity 0? Okay.
Yes. Okay. So it will be 0. Okay.
All right, that makes sense. 0. Then for negative infinity, then well, 2 to the negative infinity power, I guess, would just be negative infinity as well, right? Or not negative infinity, it'll be infinity.
It is 2 to the power of negative infinity plus 3. So that would be 1 over 2 to the power of infinity plus 3. 1 over, that means power means it will be 1 over 0. It total will become 0. 0 plus 3. It will be 3.
So it's 3? Okay, 3, yeah. So it's 0 plus 3.
It will be 2 to the power of negative infinity. That you can write as 1 over 2 to the power of infinity. It's a negative exponential plus 3. So 1 over 2 to the power of infinity is nothing but infinity. Sorry, 0. Okay? 0 plus 3 is 3. That's all. Okay? You want me to write it or you're clear?
No, I'm good. I'm clear.
Okay. Use the sandwich theorem. You know what is the sandwich theorem? That's taught to you?
I don't know the sandwich theorem, but I don't think that's going to be what we're tested on. But can we move on to like the next topic if it's all right though?
Yes. What is the next topic? We have it here. One second. Okay, limit optimization it is, right? Okay, just let me take this. Optimization. One second. The next topic. Just give me a second. Where I will start. This is limits. Just now I saw the optimization. What happened? 1 second, Josh. Oh my God. It will be coming along with this implicit differentiations. Okay, I have got it for implicit differentiation. Can we do that? In the meantime, I'll just take for optimization.
Sure.
Yes. Okay. Let me. So let me take a worksheet for you for implicit differentiation. Let me share my screen. Okay, Josh. Here it is. Find gy by dx. They have given this one.
Got it.
In this itself, you have the finding the slope of the curve and everything. Okay.
Mm-hmm. So for A, it's gonna be
Mhm.
sorry. For A, it's gonna be 5x over negative 6y squared minus 3y equals dy dx.
Yes. Okay. For B.
Mm-hmm. Sorry. Quick second. So for B, it's gonna be 3y squared plus 2 over negative 3y equals
No.
dy
It's
dx.
no, George. It is negative 3xy minus 2 over 3y.
That's what I said. Negative 3y squared plus
No,
2.
no, no. I'm saying one. Give me a second so that I can write it on this one directly.
Oh no, wait. Can
I'm
you just go
saying
back
it
to
is. I'm saying it is negative 3xy minus 2 divided by 3y is nothing but your dy by dx. I'm saying.
yeah? Didn't I say 3? Oh, sorry. I meant to say
You
3x squared plus 2 over negative 3y. Is that
okay?
it?
You are not taking the common term there. Okay, I'm writing it here so that no confusion. I'm getting
Oh no.
negative.
Yeah, negative 3x squared plus 2 over 3y. I just wrote it basically with the negative in the denominator,
Okay,
essentially.
okay,
Sorry.
okay. Then fine. Okay, next one. Option C.
So I got negative sine x divided by cosine of y minus 1 over y
Yes.
equals dy dx.
Sine of y minus
Yes?
1. Yeah, cosine of y minus 1. Yeah. Okay, then.
No, wait. Cosine of. Wouldn't it be y 1 over y? Or would it just be 1?
No, it is cosine of y minus 1. That's all.
Oh, okay.
Because it will be cosine of y dy by dx minus dy by dx, and you will take the dy by dx as common. So you will
Okay.
get cosine of
But
y minus 1.
okay. Yeah, sorry, but it's just that when using logarithmic differentiation, you don't differentiate y as just 1. You differentiate it as 1 over y times dy dx.
Where is that algorithm differentiation you have here? What?
Never mind. I was just thinking of that. Sorry.
Ah,
Never mind.
okay. Next one.
Okay, so yep.
This one.
So it's 3x squared plus 2 divided by negative sine of y cubed times 3y squared.
Yes, right. Okay. Now you need to find the slope of the curve at the point 1, comma 2.
Mm-hmm. So I got negative y squared minus 2y divided by 2xy plus 2x.
No, you have to find the slope for this one.
Yeah, that's what I looked for. I found the derivative of xy squared, and that's 2xy dy dx plus y squared, and then the derivative of 2xy, which is just 2x dy dx plus 2y. I bought the y squared and the 2y to the opposite side, basically, since the a turned into a 0 when its derivative was taken.
Okay.
And then
You
for
just
the
tell me
dx.
what is the slope you have got. I mean, at the point 1, 2.
I forgot to plug in. Sorry, give me 1 quick second.
Yeah.
It is. Give me a second. 0.
No, it is negative 8 over 6 or negative 4 upon 3. I think you are making something.
Oh wait. Oh, sorry. I meant to say Yeah, sorry. It's negative 8 upon. Yep. Sorry, I didn't mean to say 0. Sorry. Over 2 times. Give me 1 quick second. Negative 8 over 10.
No, negative 8 upon 6.
Negative 8 upon 6.
Yeah.
Well, I'm sorry. I can't do math. It is 8 upon 6. Sorry. It's just that I'm running out of space over here. I'm losing track of everything. You're right. I'm sorry.
Yeah. Okay.
I just added it incorrectly. It's just that I'm losing space on this page. I'll just get a new one. Sorry.
Oh, yeah. Okay, next one. You need to find g squared y by dx squared.
Yep.
Okay, second.
Would the second derivative just equal 1?
Yeah, okay. Oh, no. You are finding for the third question, right? We don't have any point or something. It will be. What is your first derivative you got?
First derivative of 2y dy dx equals 2x plus 2.
Well, yeah. So dy by dx will be 2x plus 2 divided by 2y. Am I right?
Yeah, so then it'll just be x plus 1
over
over y equals
y.
dy dx.
You just
then I'm
you have
sorry.
to do the quotient rule for that, for the second differentiation.
Right. Sorry, I didn't do that. I left it the way it was. I did that. Sorry.
Okay.
So it's
yeah.
So I got y over x minus 1.
Getting y squared minus x plus 1 double squared divided by
y over x minus 1.
No, not. I'm getting y squared minus x plus 1 double squared divided by y cubed.
But why is it y squared though?
Because when you differentiate, you will get it out, right?
No, when you differentiate it, you get 2y for the first derivative, 2y dy dx equals 2x plus 2. And so then if you were to divide, you would
have to differentiate now x plus 1 over y, not the first one again. When you are finding the second differentiation, you have to differentiate dy by dx again.
Well, yes, I understand that, but no. For the first derivative, you would get 2y dy dx equals 2x plus 2.
Yes, George.
First derivative.
Yeah, so it is 2. If you cancel, you will get x plus 1 over your dy by dx. I have got to be x plus 1 over y. Am I right?
Yes,
now
and so then
you have to differentiate this one. So it is y times. You have to use a quotient rule for this. So
yeah, so then
1 minus. It is x plus 1 times dy by dx.
Minus. Yeah.
Okay. Divided by, it would be y squared. Right?
Yeah.
Now you
And
need
so
to
why?
substitute.
And so yeah.
You
And so
cannot
then
keep
basically.
this. You cannot keep this dy by dx here. So you have to
Oh,
replace your x plus 1 over y here. Because I want
right.
the answer in
Okay.
terms of that. Okay, just substitute and
Okay.
get the answer.
Mm-hmm. Yep. I understand.
Okay. Just substitute and let me know the answer if you're getting that.
Mm-hmm. Yep, I'm getting that. The same thing.
Okay.
Y squared minus x plus 1 squared over y cubed.
Yes. Okay. Next one, find the points at which the graph has a vertical tangent line. So you need to find dy by dx for this.
So I got negative 4x plus 4 divided by y plus 2.
Yes, right. So now find the values of y and substitute it and find the values of x. What are the coordinates you are getting? You need to tell.
But how would you find the coordinates, Sally? We just plug in random
You know
numbers?
the vertical tangent line, right? So you have got, I'm not simplified that. It's 8 minus 8x, 2y plus 4. That's the dy by dx.
Yeah.
For
Mm-hmm.
the vertical tangent line, you have to equate the denominator to 0. So from that, you
Oh,
will get your
okay.
value of your y. I'm getting it to be negative 2.
Negative 2. Yep.
Substitute it in this equation, okay? And get your value
Okay.
of your x. That will be the coordinates for
Mm-hmm.
you, okay? Just substitute y equal to negative 2 and find the values of x for this.
I'm. Oops, sorry. I'm getting 0 and 2.
Yeah, 0,
Yep.
yeah, 2. Correct. Okay. So the coordinates you will write it as 0, comma negative 2, 2, comma negative 2. Same way
Mm-hmm.
horizontal tangent line. For this dy by dx, you will find it out. But you will equate here the numerator to 0 and find the values of the denominators. Okay? Okay, Judge?
Mm-hmm.
Okay. So the next one, I'll just take it out. Okay, you want to go with the same topic or you want to go for the next topic?
Next topic. If you have optimization problems, if it's okay, or
Yeah, yeah,
anything
yeah.
else.
Yes, 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 yes. Just give me a second. I need to take the optimization. I already opened one optimization and kept it. That would be fun. Yeah, solving optimization. Just give me a second. It would be along with the answers, but we won't see the answers. Okay, just give me a second, Josh. One quick second. One second, I'm closing it out. It's along with the answers, okay, but we will just do the problems and then check cross-check the answers, okay?
Mm-hmm.
Just a minute, I will share my screen.